Okay, this is the I'm gonna make it smaller. This is the data file for what we have in the slide. Okay, you can see this data file is moving average with 3, so you calculate the average of previous 3 data. Right, unit sold, that's the one. So you can just see this is the average of past 3 data, and then this one is the average of past 3 data. This is the average of past 3 data. So that's a moving average with 3. And exponential smoothing, the first one is just taking the first variable. So yeah, this one I will. However, the second one, now you are using this formula. So what was the formula? It's a forecast of the t is no, should be forecast of the previous one plus alpha of the a t minus 1 minus f t minus 1, right? So your calculation is something like this. Here, your previous ft, right? So this one is a previous one, E2 is the previous one time plus alpha times previous actual minus previous forecast. And you just copy the formula all the way down, right? So that you can have a same formula every time, and you can get a right. This is only just increasing the decimal, so I can reduce. Right, so exactly the same number. This one is the same calculation, but only difference is the alpha is just 0.1, and you can draw the graph. This one is the plot. We plot using only the I will delete. Plot the only the actual data. Once you plot the actual data, so I didn't specify the x value. So x value is the first one, second one, third one. Once you draw it, how can I get this formula? Yeah, of course you can run the regression, but the simplest way is that you just click the data point here. So if you click one more time, I think you are selecting only one data point, right? This is not selected, only this one. But if you selected it once, then you are selecting all of them, and then using mouse right click, then you can see the option is add trend line. Then you can just simply add a trend line, and then you can specify the exponential, logarithm, and so on, but I will choose a linear. And also you can choose option display equation on chart. So in forecasting, I don't care if there's a high R square or not. Higher R square, that's better, but I'm trying to capture the trend. So R square is not that important here. Because we will figure it out the seasonality also. So I'm just trying to drag out only the trend. Doesn't matter trend is the most of the can explain the most of the movement or not. That's not important here. So you choose the option, the display equation here, and then you go back. Then you can see the equation here. So simply I just increase the font. Now you can tell what would be the number. Next step is you can just plug into the 13 to the x, then you can predict the next step. I mean only the trend part. Okay, TAF is trend adjusted formula. So this is just exponential smoothing, right? This is the Okay, this is what. This is just the TAF. So at the beginning, because the TAF is using the 2 exponential smoothing, so we have to just take a original number. How can I get a T here? 9.33 is the 9.33 here is the number calculating the slope of using this 4 number. So just previous number. So you can tell how much think about it. This is just 1 first period, second period, 3, 4. So x changes to 1 to 4, right? So if you calculate the slope of this line, 200 to the 228, that's the 228 minus 200 divided by 4 minus 1, right? So that's of 9.3333. So your initial 9.33 is using previous information. How much it changed by when it x changed to the 3, 1 to 4 is changing, increasing by 3. How much y increasing? So it's like a slope. So once you got this one, your next TAF is a S plus T. So how can I get a S? It's using exponential smoothing. So exponential smoothing, you have to use the previous one, right? You cannot use this one because you don't know what is actual here. So you cannot calculate this number. This number requires the actual. So this one is adding the previous 2 number. So you got a TAF, and then S, you're gonna update it as using exponential smoothing, right? So exponential smoothing. This one, C9 plus alpha times your TAF, I mean the actual minus TAF. That's your new S. And your T also calculating different, this is a beta, okay? So different TAF and then your previous T. So you're adding, I think I can show you the formula here, right? Your new T is old T plus beta times TA, difference of the TAF minus previous T. So in that way, we are calculating here previous T plus beta times difference between TAF minus previous T, and you calculate update. Now these two will be added to the next TAF, right? And you keep going on. So you are using actually the exponential smoothing twice, and then you just add up. As a result, okay, this is just exponential smoothing with alpha 0.5. If you take a look at it here, right? Blue one is actual, and then this gray one is exponential smoothing. Again, exponential smoothing, just like a moving average, this going up is actually has a delayed. It's catching up to the slope. However, that happened with like a 1 or 2 period later, right? So that's a lag. But if we use a TAF, actually our forecasting, obviously this is not exactly, it's not correct, but actually it move with the data point indeed. So you catch up to your movement pretty quickly. Seasonality is regularly repeating. Again, it's every year it happen. It doesn't have to be the actual, even though the name is seasonality, doesn't have to be related to the season, spring, summer. It doesn't have to. It can be every March there is something happen. Similar to like in like an Asian country, because the school start at March, right? Or in US or Western country, actually school start at late August or early September. So what is the characteristic of that period is when you know, like Apple or Microsoft, they do the kind of promotion for the new student. They sell their laptop and iPad, tablet, and so on. So you may have a lot of the demand peak when the school starts, right? But that's happening every year. That's not related to the season itself, right? But every same time period, every year, that's happening. So that's what we call the seasonality. So regularly repeating movement, right? In the year, that's the important part. Okay, so we can model the two different ways. One is additive, the other one is multiplicative. So additive means every like March when the school start, our sales go up by a certain amount. So every year our sales going up, but every March we have even more. So like every time we sell 5,000 more. That's additive. So you are adding certain amount, 5,000. We are selling every March because of the new student. We sell 5,000 more than our regular sales. Or multiplication is like we sell always 20% more. This is like a 20% more, right? This is the multiplicative model. So our sales is always going up, right? But every March we have a little bit more. Every March we have a little bit more. We have a little bit more. You can consider this is just an additional portion that's additive, or compared to your current sales, this can be a 20%, then which means this is getting bigger and bigger, and this is getting bigger and bigger. So this much is the 20% of the total amount. So when this actual number is getting bigger and bigger, the additional part is also getting bigger and bigger. That's a multiplicative model.